Hey class, continuing this set of notes on moles, we're going to talk about another conversion factor, which we brought up in the last video, but we want to go through some calculations with it here. 1 mole is equal to the molar mass, and I want to add here in grams. So if I want to go from mass to moles or moles to mass, if I want to do a conversion between mass and moles, the molar mass is equal to 1 mole. The molar mass is the mass of 1 mole of a substance. The molar mass can be obtained by using the periodic table. It is the atomic mass. So for right now, we're just talking about atoms. It's the atomic mass. So what we're going to do is we're going to make our possible fractions. We have our molar mass, in grams. So you have some number, the molar mass, and then we're going to put grams as our units, over 1 mole. Or we can have 1 mole on top and the molar mass, again replace that with a number in grams. Now the reason we just give you the word molar mass instead of giving you a number is because it depends on the element you're dealing with. When we're talking about molar mass, every atom has its own atomic mass. So it's specific to what type of element you're talking about. I've got the periodic table over here to the right-hand side. So you can see that hydrogen's got a mass of 1.008, beryllium's got a mass of 9.012. If we go across to find carbon over on the right-hand side, 12.011. Helium is 4.003. They've all got their own molar masses. Those are atomic mass is another name for the molar mass of an element. Now let's look at potassium. K. 3.4 moles of potassium, and I want to know how many grams it is. I know that I'm going to put moles on the bottom and I want grams to be on top. Well, if I want grams on top and moles on the bottom, I'm going to use this one. We'll use conversion factor number 1. We'll call this one conversion factor number 2, and we'll get back to that. So what I need is the molar mass of potassium. So let's go to our periodic table and find K. There it is, 39.098. .098 grams using that format that we had up above in conversion factor number 1. And then we put 1 mole of potassium on the bottom. So 1 mole of potassium has 39.098 grams. Remember, that is specific for potassium. Let me pull my calculator up. So 3.4 times 39.098 divided by 1 equals. And I get 132.933. Remember, our sig figs are going to match what we have in the problem, and since I have 2 sig figs in the problem, I need to round this to 2 sig figs, which means I want to keep the 1 and the 3. Now think about your rounding here. Is 13 just a rounded version of 132.9332? No, it's not. So we got to put 1, 3, and then put a 0. 130 is close to 132.993 or 9332. Okay, so 130 is the way we would round this to 2 significant figures. Grams of potassium. All right, let's go down to the next step. Next problem is 129 grams of sulfur. Okay, we're going to multiply by a conversion factor. Let's look at which one. Well, if I have grams of sulfur and I want to cancel that out, that means I need to have grams of sulfur on the bottom. So I'm going to put grams down here. And if I'm talking about grams, that means molar mass. I'm going to have 1 mole on the top, just like in conversion factor number 2. And I've got to find sulfur so I know what the mass of 1 mole is. Sulfur is over here. Its mass is, and it's kind of blurry, but it's 32.066. .066 grams. Pull up that calculator again. 129 times 1 over 32.066. Enter. We get 4.0229, so on. 3 significant figures would just be 4.02. And the units are whatever's on top in the last step. It's moles of sulfur. You could write that in the blank if you wanted to.